Hi, this video is about Singleton design pattern. Actually, this is a part 1 of Singleton design pattern. And this happens to be the first video on a series of design pattern videos I'm planning to publish on my YouTube channel. Why did I choose Singleton design pattern as the first video? There is a specific reason behind it. It's primarily because this is one of the most widely misunderstood and widely misused design patterns out there. For example, a candidate walks in for an interview and you ask him, what is your favorite design pattern, or what are the design patterns you have used in your project? So the first answer that generally comes back is Singleton. And they say that generally because it's very easy for them to remember its definition, and it's very easy to explain it with a simple example. But actually, in real world, Singleton, it's not very easy to get it right. So in this video, we are going to explore why is it hard to get Singleton right. So let's start with the definition. The definition says, ensure that a class has only one instance and provide a global point of access to it. So that means across your application, you're going to have only one instance of that class ever created. And whenever you need it, you're not going to create using a new keyword. Instead, you're going to use a well-defined global point of access to it. So let's take a look how we implement a singleton in a programming language like Java. So the implementation basically has to follow these two rules. First is make sure that there is only one instance, that is a sole instance. So that means we will have to make sure nobody else is able to construct this class using the new keyword, or we will have to make our constructor private, and the class itself is going to manage its instance. And second point that we have to follow is that we have to provide a global point of access to the single sole instance. So that means we might have to define a static public API that will return the sole instance back to the caller. So now let's take a look how we will implement this using our IDE. So let's go here, and I'm going to create a new Java class and call it Singleton. So let's follow the two rules that we just discussed. First is make a private constructor, private singleton. And so by this, I've made sure that nobody else can create my class object using a new keyword. So I'm going to say creating. And second is provide a global access point. So that's going to be a public static API that returns the sole instance back to the caller, get instance. So here I'm going to return my sole instance. So the sole instance I haven't created yet, so I'm going to define it as a field, a static field in my class. And for easiness, I'm going to just create the instance right here, singleton. So that means whenever my singleton class is loaded by a class loader, it runs the initializers and creates the instance and assigns here. And once it is created, this instance is ready, and whenever somebody calls the get instance, he gets that instance back. At the same time, since the constructor is private, nobody can create a new instance and violate our requirement that there should be only sole instance available throughout the application. So now, since we have successfully defined a singleton class here, let's run a few examples and see are we really able to create a sole instance and kind of conform to the singleton design pattern definition. So I'm going to create a little test class here, class test class. And this is going to contain a main method. And in this main method, I'm going to create two singleton instances and going to compare their hash codes. So in general, in Java world, most of the time, if two objects have same hash code, that could mean that they are pointing to the same reference. So that's true for most of the cases. So I think that's a good enough test for us for right now. So I'm going to do that test. So I'm going to say singleton s1 equal to new singleton. That's not allowed because we made the constructor private, so nobody can create an instance of their own. So we will have to use the global access point, which is the get instance. So I used get instance and got a reference back. Now I'm going to create one more singleton using the same get instance API. So I got two references. Now, if they were the same sole reference for my application, their hash codes should be same. So I'm going to create a method called print s1 and s1 and call it for both s1 and s2 that prints an output for us, which is like this: static void print string name singleton object. And here I'm going to just print something like system out string format. I'm going to say object is this, hash code is this. And I'm going to pass my name and object dot hash code. So don't worry about this print method, it's just printing the object name and its hash code for us. So let me run this example and see how the output looks. So if I'm successfully able to create singleton and return my sole references, these two prints should give me the same hash code because I'm printing s1 and s2. So I should be able to see the same hash code. Let's watch the output for this execution. So yes, so first it called the constructor because the class got initialized during class load. And then I got two instances, s1 and s2, and I printed them, and I'm getting the same hash code back. So here, simple, we have successfully created a singleton. And we can really celebrate saying, yes, we have nailed it down, but we haven't really addressed a lot of hidden issues here. So let's see, why are we saying that it's hard to create a singleton right? Let's go back to the presentation and see why we're saying it's hard. So it's hard because we can violate the requirement of sole instance using following points. So as you know, there is a reflection API available in Java that lets you call, the constructors and methods of an object using introspection. So reflection allows you to really construct a singleton object without really using its new instance or any other API like that. So we will let's definitely quickly take a look how reflection can violate the singleton requirement that there should be only sole instance. So what we are going to do is we are going to use reflection to create a new instance. So I'm going to load my class first, class.forName, my package dot class name. So this way I'm going to load my class. It's going to throw a bunch of exceptions, so I'm going to add it here. Throws exception so that I don't have to deal with the individual exceptions for now. So I'm going to say class equals class.forName patterns.singleton. So here I've loaded my class. Now from this class I'm going to get the declared constructor of the default constructor. So I'm going to assign it to a constructor type of singleton constructor. So I got the declared constructor, default constructor. Now since it's private, I cannot really invoke it. So what I'm going to do is going to use the set accessible API, which actually lets you violate encapsulation in Java and change the access modifiers. So by doing this, in this context, I'm changing the constructor to a public constructor. Now I'm going and invoking that constructor, new instance, and creating a new singleton here, S3. So now we have created a new singleton. Now what happens? Let's print S3 and its hash code. So now if we run, if it shows the same hash code as S1 and S2, we are good. Our singleton is working fine. But if it is going to show a different hash code, we have successfully created yet another instance and violated the sole instance requirement. So now let's run this example and observe the output. Okay, so first we successfully created a single reference and assigned it to S1 and S2 using the get instance API. And so we are seeing the same hash code here, but at the same time, when we used reflection, we got S3, which has a different hash code. So that means we have successfully violated the singleton requirement. Now let's go back and check what other ways we can break the singleton. So next way that we can break a singleton is using serialization and deserialization. So serialization is the process by which you can write your object representation to a stream, like a file stream or something else. So that representation is written to the target resource, and later you can read it back and construct your object back by deserialization. So if you do serialization and deserialization of your singleton, you can effectively break the sole reference requirement. So now let's go back and try to break it from our test class. So for a class to be a serializable class that can be written to the external resource, we have to implement a marker interface called serializable. So I have added that to my singleton definition, and I'm going to create a serialization example. Now let's see what happens. So here I'm going to create an object output stream, a new object output stream of new file output stream to my temp folder, where I'm going to write the S2 object to a file. And so here's the thing, oos.write object and the object name S2. So this will write my object to the stream, to the file. Now let me read it back using deserialization. Object input stream, new object input stream of new file input stream, same file, tmp s2.ser. So this is gonna read the object back and reconstruct the object state. So I'm going to assign it to a singleton reference, singleton s3 equals ois read object. So now I would need to cast this to my singleton. No. Okay. So here I've reconstructed my object back to S3. So ideally, if the singleton is perfectly working, when I print S3 details, I should see the same hash code as S2. And then my singleton will be a true singleton. But in this case, let's see what happens. So let's go ahead and rerun the example with serialization. So now we are seeing that object S1 and S2 are still fine, and then I serialized S2 and then deserialized it to S3 and is having a different hash code. So again, we have violated the singleton definition. So let's go back and inspect the next way by which we can violate the singleton definition, and that is by cloning. So now let's back and try to see how that happens. So I'm going to get rid of this again, and I'm going to implement another interface called clonable. So when I implement this clonable, I will be able to override and use the clone API, which by default calls the super clone API. So I'm just leaving it as is, and I'm gonna clone my object to a new reference, singleton s3 equals s2.clone. So this also requires a cast. So we are ready. So now let's run this example, and ideally if the singleton is perfect, we either should not be able to clone it, or if when we are cloning we should get the same reference back. So now let's see what the hash code for S3 looks like. So I'm going to run it. Let's observe the output. So as you can see here, again S3 has a different hash code, meaning we are having yet another instance for the singleton in memory, which clearly violates the singleton definition. So that's about cloning. Next way by which we can violate singleton is throwing the singleton out in a multi-threaded environment. And this is one of the most dreaded scenario, because when multiple threads are trying to create your singleton, it will actually cause a little chaos, especially when you are creating a singleton using lazy loading. So in our example, what we have done is that we have eagerly created the instance here. But this is always not a very good approach, because first of all, sometimes you may not really need your instance until it's really needed. For example, until the get instance is called, you don't really need to construct your singleton, especially if the singleton creation is a very expensive operation. So what you would do in that case is you would delay the creation until it's demanded. Okay, so in this example, we are going to initialize it lazily. And also, yet another benefit of lazily initializing your instance is, suppose during class load, it's trying to create a new instance and the creation failed. So you don't have a chance again to recreate that instance until you reload the class. But in lazy loading, if the first attempt fails, the second attempt may succeed, right? So we are going to set this to null, and then we're going to try and create that lazily here. So here we go. So here we check if sole instance is null, we are going to create sole instance equals new sole instance, singleton, sorry. So now for the first time when we call get instance, at that time we check if sole instance is null. If that is null, we go ahead and create a new singleton and return it. So since that is a static variable here, every time you call it the get instance again, it will be already initialized, and you will always skip this if block and come here and return your instance. So this is basically lazy initialization. And the point here is, when we throw this out to the multiple threaded environment, what will happen is one thread will enter here and see that the sole instance is null. Another thread also at the same time see that the sole instance is null, and they both will end up creating new instance and assigning it, and thus violating our sole instance requirement. Sometimes it may work. Sometimes one thread may come here and see that sole instance is null and successfully create, and then the other thread will enter and successfully see that the sole instance is initialized to some valid variable, and then it will return. So sometimes it will work, sometimes it may not work. So that is one of the most dreaded scenario, because if there is a bug that sometimes works and sometimes does not work, that becomes it makes it really difficult to debug and fix. So now let's see how multiple threads can really cause trouble in this singleton. So here I'm going to get rid of all this code, just retaining my print in my test case. And one more thing that I'm going to do is I'm going to just create an example scenario here, like static void use singleton. So assume this is one of your service APIs in your application that's going to use your singleton and do something, right? So here I'm going to do singleton equals to singleton dot get instance, and then I'm going to just print my singleton. That's all it's doing. But basically in your application, you might have scenarios where you're calling the singleton and doing some operations, and multiple threads can access that method at the same time and enter into the get instance, right? So let's try to simulate it using an executor service. Executor service equals executors, and I'm going to create a fixed thread pool of 2, because I'm going to have 2 threads in this example. And those 2 threads I'm going to submit to my service as runnables. And I'm going to use the Java 8 Lambda expression to do this. So don't worry about the syntax here, but just understand that I'm going to submit 2 new threads that are going to invoke my useSingleton API in test class. So this is as good as writing two new runnables and starting them. These two lines. So here I've created two new threads and started them. And then let me shut down my executor. So here I've shut down the executor, and by that time it would have executed. So this is the example that I'm going to run now to demonstrate how these multiple threads can violate the singleton instance. So now when I run, if multiple threads are causing trouble, we would see two different hash codes getting created through these two invocations. There. So right in the first example, the singleton got violated, and I got two different instances created by these two different threads. And as you can obviously see, the creation executed twice, and you have two different hash codes as well. So let's execute this for fun again and see what happens. Again created. I'm executing it again. So yeah, I wanted to hit this scenario where sometimes it's working. See, though I submitted two threads in this case, the singleton got created only once, and both the threads saw the same instance. So see, as I said, sometimes it will work and sometimes it won't. And that is kind of a most dreaded kind of defects that you might have to deal with if something is going wrong. So that demonstrates how lazy initialization mixed with multiple threads can violate your singleton definition. So now let's see what are the other scenarios. Next is multiple class loaders. So multiple class loaders can violate your singleton by loading them independently. So how that could happen? So in environments like you have a web app container where you have a web application class loader and the separate, the enterprise archive class loader, right? So let's assume that scenario and assume these two class loaders are not really directly dependent. So what will happen is whenever a class loader loads a class, it will check its parent to see if the given class is already loaded in the parent, then it will just use that. But if not, it will try to load its own. So let's assume these two class loaders are not really linked through parent-child relationship trees or whatever. Right now, you start up your container. Suppose you're in a web container, you are referring to your singleton. So web app class loader will load that singleton. And suppose in your EAR you're referring to your singleton, that will also load the singleton at the same time and get a new instance. And by that way, you would have created two separate instances of the singleton in the same JVM. So that is how multiple class loaders can cause havoc in your singleton definition. And that's one of the most difficult thing to fix about singleton. And most of the cases, developers just leave it alone and don't really bother about that scenario. But in theory, you have violated your singleton. Last point is about garbage collection. So this was like an old concern, probably early 2000s or late 1990s, when Java 1.2 was still not out. What would happen is static references like singleton could get garbage collected at some point. And when you call the new instance API again, it'll create and return a new instance to you. So as of 1.2 version of Java, this is addressed, so we don't have to really worry about this. But I just wanted to include it in the discussion. So there used to be more ways by which your singleton can break. So this summarizes my first part of this video, and here in next part I'm going to explore how are we going to fix these issues in code, and what is the significance of singleton in our application when whatever a singleton does you can achieve by using a class with static members and static APIs, right? So in that discussion we'll see what is the real significance of a singleton. And finally, I just wanted to touch upon a couple of examples of singletons. So why would you use a singleton at all? So there are scenarios like where you want to represent a sole one and only one concept across your application. You would really use a singleton. For example, in JDK, there is a class called runtime, and that is a singleton class. And there is a reason why it is a singleton class. It's because when you run your application, you have only one runtime available to it. and that is the sole runtime that is out there for that running class. And whenever something else modifies their runtime, everything else should be able to see that change and accordingly change something and do something. So that is one practical example that is out there in JDK itself. And then we have in real applications you would use something like a log manager that would hold the log configurations and details like how to write the log in what pattern and things like that. And that single log manager should be available across your application so that all logging happens uniformly, right? And then you might use singleton in scenarios where you want to represent a heavy cache or a configuration that is read from various different resources, and you don't want to recreate that cache in different contexts. Instead, you want to just reuse the one single instance that is available to you. And one more area that where singletons are used are like the resource managers, like DB managers that manages connections and things like that to a database. You may not want to create new instances every time somebody wants to acquire a connection, and thus maintaining multiple pools of connections and causing a real mess in your application. So these are some examples of singleton in real life, and we will see how to fix these issues that are listed here in our next video. Thank you.